Hi, this video is part 2 of conditional probabilities. We are picking back up with example 3 on conditional probabilities with tree diagrams. When we left off, we had just finished finding the probability of boy and girl, where you multiply the probability of boy times the probability of, boy and 2. So you multiply the probability of boy times the probability of 2. Now we're picking up on this third part, finding the probability of 2 given that they're a boy. So what I want you to think about this time is not multiplying two probabilities, but actually thinking what part of the tree diagram shows only boys. So if we already know that they're boys, we can basically ignore this half of the tree diagram. We do not need it to solve the problem. So if you notice, our sample space actually changes size. Instead of having 8 in our sample space, we only have 2. We have boy 1, boy 2, boy 3, and boy 4. So now that we only have 4, that 4 will become the denominator, since that's our new sample space size. So finding the probability of 2 given that they're a boy means you know that there are 4 possibilities. What is the probability of choosing 2? There's only one option that has 2 out of the 4. So therefore, the probability of 2 given boy is 1 out of 4. No multiplying necessary. Next, we have to find the probability of choosing an even number given that they're a girl. Again, when you see given, you want to ignore or cover up the other part of the tree diagram, because that deals with boys. So given that they are a girl, again, there are only 4 possibilities, choosing 1, 2, 3, or 4. So now our sample space size, our denominator here, will be 4. Of those 4, how many of those numbers that we could choose from are even? Well, the numbers 2 and 4 are even. So that means we have 2 possibilities out of 4. So with given, remember to cover up the part of the tree diagram that's not necessary. Next, we're going to move on to example 4, conditional probability with Venn diagrams. This says to create a Venn diagram. So what you want to do to create a Venn diagram is determine how many different categories there are, so you know how many circles to include in your Venn diagram. It says there are 20 students who like baseball, 30 students who like football, 15 students that like both sports, and 5 students that like neither. So it appears that the only 2 categories we see are baseball and football. So my Venn diagram will consist of a box with 2 overlapping circles. Now, what you could do is relate this to a frequency table. If we were to create a frequency table, which we've already done, when they tell us we have students that like baseball and football, and students that like both and that like neither, don't like either one of them, we recognize that we should probably have that they like baseball or that they do not like baseball, and that they either like football or they do not like football. So we've done this before, so I'm trying to tie that in. Reading it again, it says there are 20 students who like baseball. It does not say that they are students who like 20 students that like baseball and football. So that 20 is going to represent our baseball total. They then say that there are 30 students who like football. So like football, we have 30 students who like football. 15 students like both sports, so baseball and football. And it says there are 5 students that like neither. They don't like either one. Well, now we can just think algebraically about how to find our missing number. So 15 plus what equals 20, and that's 5. Horizontally, 15 plus blank equals 30. That's going to be 15. We can also find our totals. 15 plus 5 is 20, and 5 plus 5 is 10. Remember to always include your total, and that the sum vertically, 30 plus 10, should also be the same as the sum horizontally. 20 plus 20 is 40. Well, understanding that will help us understand how to fill in our circle here. They tell us that there are 20 students who like baseball. So I'm going to let this be the circle for baseball. And I know that there are 20 of them. I do not put the 20 inside because it is the total for baseball. Those that like football and baseball, and those that like baseball only. They also tell us there are 30 who like football. So I'm going to let this circle represent those that like football. And I know that there are 30 of them. Again, do not put your totals in your circle. 15 students like both. For a Venn diagram, the part where they overlap is where you put the students who like both. And it says that 5 students like neither of those sports, so that's going to be in the Venn diagram but outside of your circles. Hopefully now you'll understand that, like we figured out the numbers in our frequency table, that if we have a missing number that's added to 15, it must equal 30. So to find that number, we should subtract. 30 minus 15 is 15. Likewise, 20 minus 15 is 5. Notice that all the numbers in the Venn diagram are just the same as the numbers inside your frequency table. The totals go on the outside of a frequency table, and likewise the totals go on the outside of the Venn diagram. The last thing we want to include on our Venn diagram is the total number in our sample space, which I generally put outside because it's not included in these. But if we add 5 and 15, that gives us 20, plus 15 is 35, plus 5 is 40. So we want to make sure that we indicate that there are 40 total in here, same as there are 40 total in our frequency table. We have now completed construction of the Venn diagram. The first part, if you look over on the PowerPoint, says to find the probability of both, meaning the probability that they like both baseball and football. Again, that's going to be where they overlap. And you can now see also the necessity for finding the total of 40. So both, there are 15 out of 40. No multiplying necessary. For next, the next one says find the probability they like both given that they like football. So this is where it gets a little bit different too. Similar to the tree diagram, we only want to look at and consider the survey respondents who do like football. So if you look at this Venn diagram, that means I want to ignore everything except football. So as you can see, there are now 30 in this sample space because I'm only considering that they like football. Your denominator of your probability will always be the total for the given. So there are 30 that love football, so that's going to be my denominator. So what this is asking is to find the probability that they like both, meaning football and baseball, given that they like football. If you consider your Venn diagram, that would be the 15 that also like baseball. So my numerator would be 15. Again, do not reduce. On the PowerPoint, the next problem asks us to find the probability that they like baseball, given that they like football. So notice again, football is my given, so that is going to be my denominator. And now again, we actually do not need to move these stickies because the both are the ones that also like baseball. So of the 30 that like football, there are still 15 that like baseball. We're going to get the same thing. So basically it's two different ways of asking the same question. So it's not a totally different problem here. Just want to see if you can understand that. Now we're asked to find the probability that the respondent likes football given that they like baseball. Well, that means our new total is going to be the baseball total, and we want to ignore everything else. So given that they like baseball, how many do like baseball? That's going to be our denominator. Well, we know from both our frequency table and our Venn diagram that our baseball total is 20. Of those that like baseball, how many of them like football? Well, again, back to here, we're only considering the numbers 25 and 15. The 15 are the ones that like football and also baseball, so we want to use this 15. So our probability of football, given that they like baseball, is 15 out of 20. Next, if we want to take a look at this next problem on making a Venn diagram, for example 5, it says out of 40 students, 14 are taking English and 29 are taking chemistry, and 5 students are in both classes. So we see that there are 2 different subjects, English and chemistry. So out of 40 students, the 40 students tells us our sample size space, or sample space size, I should say, 40. Again, 14 are taking English and 29 are taking chemistry. We want to be careful here and not just go say 14 should go here in our English, because remember the people inside the middle are also taking English. So our English total is 14 and our chemistry total is 29. 5 students are in both classes. So to find the number of students that are in English but not also in chemistry, we take the 14 and subtract 5. 14 subtract 5 is 9. Likewise, for chemistry, there are 29 students, but 5 of them are also taking English, so 29 minus 5 leaves 24. So we always want to check and make sure that these total up to 40. And right now, if we add 9 plus 5, we get 14. If we add 24, we get 38. So what does that tell us? It tells us that out of the 40, only 38 are taking English, chemistry, or both. So therefore, the leftover students taking neither is 2. And we would put that number here in our Venn diagram. So A asks, how many students are in neither class? How many students are in neither class? And again, that's from the 40 minus the 38, which gives us 2. How many are in at least one of the classes? So if you ask these students, hey, are you in English or chemistry? They would say yes, so they get counted. Here, if they ask you, hey students, 24 students, are you in chemistry? They would say yes. If they ask these students here in the middle, hi students, are you in English or chemistry? They would say yes. So at least means one or more. One or more. So that means we do include the 9 and the 5 and the 24. And 9 plus 5 plus 24, we already found, was 38. C asks, what is the probability that a randomly chosen student from this group is taking only chemistry? Well, the only ones, so of the students taking chemistry, the only ones that are only taking chemistry and not English are these 24. So the probability of chemistry only would be 24 out of the 40 students. And this will conclude conditional probability with Venn diagrams. We will next pick up with conditional probability with frequency tables.